My name is Jill Patel from Group 8. I will explain about nonlinear support vector machines. What is nonlinear? So SVM. When we cannot separate data with a straight line, we use nonlinear SVM. In this, we have kernel functions. They transform nonlinear spaces into linear spaces. It may transform data into another dimension so that the data can be classified. It transforms two variables x and y into three variables along with the set. Therefore, data rotated from 2D to 3D. Here there is a figure. In the first figure, we can see that y and x is represent the 2D. In the in the second figure, it's represent the 3D. It's along with the set. In the next slide, a linear transformation is needed to map the data from its original feature space into new space, where the decision boundary becomes linear. After doing the transformation, different methodologies are used to find a linear decision boundary in the transform space. In a linear SVM model, we use phi of x instead of x to represent the transformed high dimensional future. So here it's an equation mean as w square upon 2. It's represent the optimal solution. When we have a problem, using this equation, we can find the optimization solution. There is a kernel trick. The kernel trick is used to learn a linear classifier to classify a non-linear data set. It transforms the linearly inseparable data into a linearly separable one by projecting it into a high dimensions. Here a function phi of xi dot. Here we use dot product of ixj. The kxixj is represent the kernel function. Kernel function is applied on each data instance to map original nonlinear data points. It's some higher dimensional space in which they become linearly separable, linearly separable. There is a different types of function of kernels. There's a Gaussian IBF kernel, sigmoid kernel, polynomial kernel. So there's a different types of function. In the Gaussian, there is a figure such like this. In the sigmoid kernel, the figure is looks like this, and the polynomial in the polynomial function, it's look like this. So it's a different types of function, different types of kernels. The advantage of kernel, we don't have to know the mapping function. Computing the dot product, phi of xi and dot xi phi of xj in original space avoid the curves of dimensionality. There are some issues in a nonlinear SVM. It may suffer with the dimensionality problem with high dimensional data. One possible way is to transform data into an infinity dimensional space, but still it may not be easy to work with high dimensional space. We know the appropriate mapping function. It is still computationally expensive to solve the constraint optimization problem in the high dimensional future space. So here I explained about the nonlinear support vector machines. Thank you. Here one question from our PPT. It's which product we used in a kernel function.